The Earth is the only home for humankind in the universe. One indispensable reason why Earth is habitable as it is now is the light and heat coming from the sun. Despite this, we Earthlings still occasionally come up with some weird ideas about the sun. The most common one is probably pouring a huge amount of water onto the sun to see if we can extinguish it. For the sun, at least 2 solar masses of water would count as a huge amount. Given the known solar mass of about 2 times 10 to the power of 30 kilograms, let's imagine pouring 4 times 10 to the power of 30 kilograms of water onto the sun and see what would happen. Could the sun be extinguished? The sun's surface temperature is as high as about 6,000 K. If only a small amount of water is poured onto the sun, it would instantly vaporize. But for an amount of water equaling twice the solar mass, things would be completely different. In fact, the sun's radiative flux could only vaporize a tiny fraction of it, while the vast majority of water would remain in liquid form and under gravity would coalesce to form a uniform water layer around the sun's outer layer with a thickness of about 400,000 km. Such a thick water layer would not only rapidly cool down the sun's surface temperature, but also block almost all the sunlight being emitted, so the sun would look as if it's really extinguished by the water. However, this situation would only be temporary, because the light and heat of the sun originate from the nuclear fusion reactions in its core. The core can undergo fusion because the sun's own gravity has compressed it to sufficient temperature and pressure to ignite fusion. The sun's temperature increases from its surface towards its core. We can call the inner region where fusion occurs the core fusion zone, which extends to about 1/4 of the solar radius. The energy released in this zone generates a strong outward force known as radiation pressure, which prevents the outer layers from falling into the core. Now the sun's mass has abruptly increased by 4 times 10 to the power of 30 kilograms, so its gravity would also increase substantially. The sun would then undergo gravitational collapse, quickly elevating the interior temperature and pressure. The heightened temperature and pressure would intensify the fusion reactions and also allow large additional regions that previously couldn't undergo fusion to now ignite, so the core fusion zone would be much larger than before. More intense fusion over a larger zone means the sun's energy output increases drastically. This energy would radiate outwards and vaporize all the water at its outer layer. Over time, the surface temperature keeps rising, and all the poured water is thoroughly vaporized. Their molecular structures are then broken down by the high temperatures, and the water is dissociated into oxygen and hydrogen, existing as high-temperature plasma. But due to radiation pressure, these materials cannot enter the core. The new sun would now emit higher energy, bluer light, and shine even brighter than before. So even if 4 times 10 to the power of 30 kilograms of water is poured onto it, the sun would not be extinguished. On the contrary, the new sun would evolve into a larger and brighter star. According to stellar evolution theory, more massive stars have shorter lifetimes. So this new sun would have a much shortened lifespan. Its core hydrogen would be depleted in just tens of millions of years. After that, the new sun would undergo gravitational collapse again due to loss of internal pressure, leading to another dramatic rise in interior temperature and pressure. This would ignite fusion of hydrogen in regions previously outside the core fusion zone, causing the new sun to rapidly expand like an inflating balloon, evolving into a huge red giant star. For normal stars of this mass, they would lose large fractions of their outer layers during the red giant phase, leaving behind a compact core that eventually forms a white dwarf after the end of helium fusion. However, the new sun might behave differently. Normal stellar composition is mostly hydrogen and helium, which are light elements that are easily lost from the star. But the new sun has an abnormal composition, having accreted 4 times 10 to the power of 30 kilograms of water. Based on the oxygen to hydrogen mass ratio of 8:1 in water, we can estimate the new sun has about 3.556 times 10 to the power of 30 kilograms of extra oxygen, roughly 0.78 solar masses. Compared to hydrogen and helium, oxygen is a heavier element more susceptible to gravitational confinement. Thus, during the new sun's red giant phase, oxygen loss might be much less significant. After the red giant phase, a large fraction of the remaining oxygen would likely fall back onto the compact core, pushing it over the Chandrasekhar limit. This is the maximum mass for white dwarfs, above which their cores would collapse under their own gravity, leading to runaway fusion of carbon and oxygen. The resulting heat would quickly propagate due to the degenerate matter's efficient thermal conductivity. This triggers an uncontrolled nuclear explosion, a type Ia supernova. The white dwarf would be obliterated, leaving behind a beautiful supernova remnant. In summary, if 4 times 10 to the power of 30 kilograms of water is poured onto the sun, it would become larger and brighter while having a drastically shortened lifespan. It might end its life in a spectacular supernova explosion. That's all for today. Don't forget to subscribe to my channel. See you next time!